All right. Okay, so now let's get started. So today we will talk about polynomials. Okay, so polynomials basically, what we'll be actually doing will be quadratics, cubic, and quartic. We have already done quadratics, and we know the form for that would be, let me see if this is, yeah, it should be fine. Okay, so do we remember the, how can I, let me see. Just make sure this, hold on a second. Oops, not this one. Oops. Yeah, okay, so for quadratics, we have general form, factorized form, and turning point form. Okay, so the what's the equation for that? So quadratic, the general form is ax squared plus bx plus c, right? So I think we all know that. And then for factorized form is a times, let's say, x minus h, x minus k. Yeah, and turning point form is a x minus h squared plus k. I think we're all familiar with this, right? For quadratics. 看不到。
老师，你的屏应该是卡住了。
哦，行，那我重新来一遍。How about now? All right. So that is the quadratics. So today we're going to extend the idea from quadratic to cubic and quartic. So general form for cubic, because we know cubic is to the power of 3, right? So it would just be ax cubed plus bx squared plus cs plus d. Does it make sense? So something like that. And therefore for quartic is to the power of 4. So it would be ax4 plus bx3 all the way to plus e. Does it make sense? So basically we just extend the idea from quadratic so that we can find out the general form for cubic and quartic. Yes, Lucy? Are you raising your hand? Okay. All right, for factorized form it's the same. All right, so we have two terms here for quadratics. Therefore, for cubic, we should have 3 terms, right? So something like that. Or we can also go ax if 2 terms are repeating itself. If 2 terms are the same, we can say a bracket square and then the other one. Yeah, something like that. Does it make sense? And therefore, for factorized form for quartic, it would be a and 4 bracket here. Or it can be to the power of 3 and times 1 bracket, or a square, another bracket square, something like that. So this is what we call factorized form. Does it make sense? Yeah. And then for turning point form, okay. So what is the turning point for this? What's the turning point for this? What's the vertex for this? Lawrence, can you please tell me for quadratic? A bracket s minus h squared plus k. Which coordinate? What coordinate is the turning point?
Y. K.
K is not a coordinate. Coordinate in terms x and y, right? Coordinates.
Oh.
The turning point, the coordinate for the turning point is? The turning point for the coordinates. Joanne, can you please tell us?
Y-intercept.
The turning point. The turning point. What's this is a turning point form, right?
Yeah, the y-intercept. Like
the y.
Wait.
We're talking about the turning point of this. What's the turning point for this? Let me ask you this. Let's say 3x minus 2 squared plus 4. What is the turning point?
2, 4.
Yeah, 2, 4. Therefore, this one, what is the turning point for this?
Oh, like for the entire thing.
Yeah.
Oh, it's HK.
Yeah, H and K. That's the turning point. Does it make sense? Okay. So for quartic, it would be the same. So quartic, we just extend the idea from quadratic, which is to the power of 2, to the power of 4, right? So therefore, the turning point will still be h and k. Does it make sense? Okay. And the basic shape for quadratic, which is x squared, is something like this. Yeah. And the turning point is 0, 0. And then the basic shape for quartic is something like this. It's actually very similar to a parabola, to quadratics, but the bottom is flatter. It's flatter. Okay. Does it make sense? And this is sharper. Okay. Quadratic is sharper, and then the quartic is flatter. Okay. So they both have the turning point here. The reason why I skip cubit is because, first of all, the equation is still the same idea, a bracket s minus h to power 3 plus k. But we don't say h and k is a turning point. We don't say it's turning point. This is turning point and this is turning point. But this one is not a turning point because the basic shape of this guy is something like this. So as you can see, there's no turning point here, right? There's no turning point here. And we say this guy in the middle in here, right? 0, 0, we say it's stationary point of inflection. So here's the word. We say this one, okay, is stationary point of inflection. So it's not turning point, okay? There's no turning point for this one. It's called stationary point of inflection. And stationary point of inflection and turning point. So we know turning point, we have, this is local maximum and this local minimum, right? So stationary point of inflection and turning point all together combined, they are called stationary points, okay? Stationary points. So stationary point is the gradient equal to 0. What's that mean? It means that here's a turning point. So here, the tangent line is horizontal. So we know the gradient for horizontal line is 0, right? And here the gradient is also 0. Okay. Yes, so this is just a briefing. You don't have to understand the gradient thing for now because we will learn that in calculus, which we actually learned a little bit before. Okay, but that's okay. That's not the focus for polynomial. But basically, what you need to know is that even though for these three they look similar, quadratic and quartic they have turning point, and for cubic function, like this form, this is called stationary point of inflection. H and K is called stationary point of inflection. It's not turning point. Okay. All right. So, which means we're going to talk about cubic for today, and which means we have general form, factorized form, and inflection point form. So I will talk about the last one first because that will be easiest for us because we learn how to use DRT, dilation, reflection, translation to sketch. So we will use the same strategy to sketch them, okay? So let's look at one example. If I want to sketch this one, first of all, I know it's a cubic function, all right? I know it's a cubic function. Now I want to apply DRT to sketch it. First of all, Lucy, can you please unmute yourself? And then let us know whether this function has any dilation, reflection, and translation. Does it have any dilation, reflection, translation?
Yes, sir.
Which one? Does it have dilation?
等一下，
Does it have any dilation?
No dilation.
No dilation. Okay. Does it have any reflection?
No.
Does it have any translation?
Yes.
How does it translate?
Move 4 units up.
4 units up and then?
And then 2 units right.
2 units to the right. That's right. Okay. And be reminded that the basic shape for this one is something like this, right? Yeah. If you don't know, you can look at here. So this is the basic shape. It's something like that. And we know this is stationary point of inflection is 0, 0. So now all the graph move we have 2 units to the right and 4 units up. So what we can do is that we can, first of all, find out the coordinates for the stationary point of inflection. So that would be 2 units to the right and 4 units up. So this is 2, 4. Does that make sense? Okay. And then we know we don't have any dilation, we don't have any reflection, so we are using this basic shape. So we just go the basic shape, connect the basic shape. But before we do it, it would be great for us to find the x-intercept, y-intercept first. So it's the same thing as quadratics. How do we find the y-intercept? How do we find y-intercept, Lawrence?
Find y-intercept.
Yeah.
Oh, x equals 0.
X equal to 0. So we sub 0 into here. So it would be -2 to the power of 3. What would that be?
That would be 4.
-2
Oh.
to the power of 3.
Oh, -8.
-8 and then +4.
-4.
-4, -4. So which means y-intercept is -4. Does it make sense? When we're sketching, when we label it, we have to label coordinates. We don't just label -4 here. We label 0, -4. And don't forget a bracket for coordinates. Okay, and how do we find x-intercept? Joanne, how do we find x-intercept?
Make y 0.
Make y equal to 0, x minus 2, q plus 4 equal to 0. And then how do we solve this equation?
Move 4 to the other side, so it's x minus 2 cubed equals -4.
Yeah, and then?
Get rid of the cubed by doing a cube root.
Yeah.
And then, so then x equals, oh, wait, let me think.
That's right. Just keep going.
And then you add 2, so then it's plus or minus.
There's no plus or minus thing here. The reason for that is because when we are doing, let's say, if I want to do 8, if I want to do square root, then it should be plus or minus, right? But it's only for square root, but it's a cube root, it's a cubic root, then you don't have to, because the reason for that is because this one, it can be, because positive root 8 times positive root 8 can be 8. Or negative root 8 times negative root 8, it can be 8. Yeah. So that's why when you square root it, you will have a positive or negative solution. But when it comes to cube root, for example, let's say for this one, right? It's 2. It's not plus or -2, because just consider, if it's 2, it means that 2 times 2 times 2 equal to 8, right? Yeah. But if it's -2, negative times -2 times -2, which is -8, is not 8. Yeah. So in this case, when this guy is a odd number, it's an odd number and the solution is not positive and negative. Only when it's even number, you will get positive and negative root. But for here, it would just be one solution. Okay. And that's also under the root, it can be negative as well. The reason for that is because, let's use a as example. For -a here, some people might think, oh, this is undefined because the teacher told us under the root, it can't be negative number. That only applies for square root or quadratic root. It doesn't apply for when here the root is a odd number, because that means -2, that equal to -2, because -2 times -2 times -2 equal to -8. See, it's -8. So that's why it can be under the root if it's an odd number. Yeah, does it make sense? So which means this is the answer. All right, so this is the answer. That is the x-intercept. Okay, so you can put this in your calculator and roughly know where it is. But when we label it, we just label the exact value. So it might be here, okay, because it's not to scale. It just roughly guess where it is. Okay, so it might be here. So it would be -4, 32, -4 plus 2 and 0. Does it make sense? So we find out the x and y intercept and also the point of inflection, station point of inflection. So now we just use the basic shape and connect them. Yeah, it will be something like that. Does it make sense? So if it's a 3-mark question, station point of inflection would be 1 mark. And then the x and y intercept would together be another mark. And the shape would be 1 mark. Does it make sense? Okay, can I please get you guys to do one so that I'm gonna write here. Can you guys try this one now? You try. Let me know when you finish so that we can talk about it. You just put a keyword on it. All right, 1 more minute. All right, so let's talk about it. So with this one, first of all, I see 3y equal to something, right? So what I should do first, Lucy, can you tell us what we should do first? Because this is not y equal to something, it's 3y equal to something. And what should I do first?
Divide it by 3.
Okay, so therefore y equal to 1 over 3 x cubed minus 5 over 3. Does it make sense? Okay, so some people ask me, how do we find the stationary point of inflection? So first of all, we need to know this one, the stationary point of inflection is 0, 0. Yeah. Yeah. And then let me ask you, how does it translate? Because we know for dilation, we have a dilation here, right? 1 over 3. For the dilation, we know that we don't actually need to worry too much because the x and y intercept, it would automatically give us the dilation. But how does it translate? Joanne, can you please tell us how do we translate?
5 over 3 down, and then cube root of 5 to the right.
No, there's nothing to the right because there's no translation to the right or left.
Oh, I thought it was like.
So see, this one is sort of like x minus 0 cube, yeah? So the point of inflection is 0 and negative. So basically we don't, because you didn't see there's a plus or minus sign for x, right? So when we say we change, for example, the previous one here, we x minus 2, which means we have two units to the right. We translate 2 units to the right. But for this one, we don't have any x plus or x minus thing. So there's no translation on s-axis. Does it make sense? We only translate 5 over 3 units down. All right. So therefore, what is the stationary point of inflection? Joanne? So this is 0, 0. Now how do we translate?
Down. So is it
Yeah. So what's the
Oh,
coordinate?
is it 0, -5/3?
Yeah, 0, -5/3. So that's the stationary point of inflection. Does it make sense? All right, so it would be something here. So that would be 0, -5/3, right? Okay, and then we still need to find out the x-intercept and y-intercept. Okay, so we make x equal to 0. Therefore, the y-intercept would be, Joanne, let's do it together. So what is the y-intercept?
0, -5/3.
Yeah, it would be still here at this point, right? And what is the x-intercept?
I got cube root of 5.
-5/3 equal to 0. So we move 5/3 to the right. Yep. And then x cubed equal to
5.
5. And therefore x equal to
Cube root of 5.
cube root of 5. That's right. Okay, it might be somewhere here. Okay, so we just go 5, not to scale, right? Yep. And then now we just want to connect them. Oh, so this is point of inflection. So here, yeah, it will be something like that. Does it make sense? All right. All good? Okay, now let's move on. Example 2. If I want to sketch this one, okay, if I want to sketch this one, can you tell me what is the difference between this one and the previous one? Lucy, can you please tell us what's the difference between this one and the previous one?
它变成了那个1/3。
Yeah, in English.
这个叫什么？怎么说？
The power?
Yeah. The power turns to 1/3 from 2 to from
Yeah,
3.
2/3 now become 1/3. Okay. Okay. Do we know any basic shape of that? Do we know any basic shape of this one? We haven't learned it, right? Okay. So this one and this one, do we know the relationship between them? They are actually inverse function. What does that mean? Remember how we find inverse function? We did that last year. How do we find inverse function? You guys remember? Y equal to x cubed. How do we find inverse function? Anyone remember? Lawrence, do you remember how do we find inverse function? No? Lawrence? We did that last year. So we swap x and y, right? So it would be x equal to y to the power 3. And then now we solve for y. How can we get y? We both side root third root. Okay, and then we get y. Does it make sense? And we know this one equal to this one, right? Raise your hand if you understand, if you know this previously. Yeah, cool. So this one equal to x to the power half, right? Something like that. Yeah. Okay, so which means this one and this one, their inverse function equal to this. They are inverse function. And what's the geometric representation for inverse function? They reflect over what? Inverse function reflect over what? I can't remember. They reflect over y equal to x. Okay, inverse function reflect over y equal to x. So what does that mean? It means that, so this one is x to the power 3. So the inverse function therefore would be would be something like that, because they reflect over y equal to x. So this one would be the basic shape for this. Yeah, so this is the basic shape. But we're not trying to memorize the basic shape, but we need to know how this basic shape comes from. Where does it come from? Because it is the reflection over y equal to x from x cubed. Yeah, does it make sense, Lucy, Joanne, and Lawrence? Okay, so now we know the basic shape is like that. Can we sketch this one? So we're still using DRT. We know there's no dilation for here, no reflection here. We have translation only. So how do we sketch it? Can you guys please have a go? I'm going to give you 3 minutes on that. Okay. All right, so let's talk about it. Lucy and Lawrence, if you finish, that's so you can look at here. So first of all, how do we translate? We translate 1 unit to the right and 2 units down. Okay, so this one is 1 and -2. But this is not stationary point of inflection, because this one, the gradient is 0, right? And then if you go like this, this one is actually vertical. And what's the gradient when for a vertical line? Joanne, do you remember that? What's the gradient for a vertical line?
Undefined.
Undefined. Okay, so this is not stationary point of inflection. Be mindful of that. Okay, and then but we still need to label it. And then we just need to find out x-intercept, y-intercept. So we make x equal to 0 so that we can find out y-intercept. So -1, this -2. Okay, so -1 √3 would third root would still be -1. -1 minus 2 is -3. So this is -3, right? So -3. So it's 0, -3. All right, and then let's continue to find x-intercept. X-intercept is when y equal to 0. So we move 2 to the right. So x minus 1 equal to 2. And therefore, x minus 1 equal to what, Joanne?
8.
8, that's right. Both sides, we cube it, right? We cube both the left side and right side. Therefore, x equal to 9. Yeah. All right, so x equal to 9, it would be here maybe. So that would be 9, 0. And then now we just need to connect them, okay? Yeah, maybe something like that. Does it make sense? Pay attention, this one is actually going down, I'm not sketching very nicely. All right, so before we move on, let's try one on your own. So let's try this one. This one we have dilation, reflection, and translation. So let's have a go on the second one. Okay, when you finish, let me know so that we'll talk about it. Okay. So Lawrence and Lucy, where are you up to now? Almost done.
I'm finding the x-intercept.
Okay.
Like the final
I'll
step.
give you another 30 seconds then. All right, let's talk about it. If you haven't finished, that's okay. So as long as you get the idea correct. Okay, so with this one, first of all, I'm going to translate that point, the inverse of stationary point of inflection. So that is to the power to the right, 3 units to the right and 4 units up. So it will be something like this, 3 and 4. Okay, and then want to find the x-intercept, y-intercept. So x-intercept, a y-intercept would be when x equal to 0. So that would be -3 √3. Okay, and then -2 + 4. It would be just like that. Okay, but how do we know where it is? So we can just put that on our cast, or we can approximate where it is. How can we approximate? So I'm going to teach you guys some algebra thing. So first of all, this one is equal to negative this. Yeah, because just like -a, q root of -a, it actually equal to negative q root a, because this is 2 and this is -2, right? So this is 2, I put a negative in the front, it's the same thing. Okay, so this equal to this. And then how do I approximate this guy? So we know 3 is between 1 and 8, right? It's between 1 and 8. The reason why I do that is because this one we know is 2, yeah? And this one is 1. So which means this one must be between 1 and 2. Does it make sense? So you don't know exactly where it is, but at least you know that it's between 1 and 2. All right. So this is between 1 and 2. So it's -1 point something. I don't care too much. Maybe 1.5. Okay, it can't be 1.5, but let's just use 1.5. All right. So this is -1.5, and then times -2, it would be +3. Okay. So and then therefore it will be 7, roughly 7. So the y-intercept would be here, 7, 0, 7. Okay, and then I want to find x-intercept. Okay, x-intercept. So I made this guy equal to 0. So I move 4 to the other side, -4 equal to -2x minus and then I divide it by -2, so I got 2 here. And then I cube both sides. So x equal to 11, right? So x equal to 11, it might be here. So 11, 0. All right, so the whole thing would just be, because originally it's something like this, right? Something like this. So now it would be something like this. Oh, sorry, it would be something like, let's see. So this is, something like that. Okay, it's not too nice, but it's something like that. Does it make sense? Because you reflect. Okay. Did you get it right? At least you got the x-intercept, y-intercept, right? Yeah. And the shape, you just you know, like originally something like that. So now you just go something like that. So you reflect. Yeah. Make sure this one is like a vertical, not horizontal. Okay, example 3. So what kind of shade is it? What kind of shade is it? It's a to the power 4. So what kind of shade is it? Joanne, what kind of shade is it? It's a quartic. And what's the basic shade for quartic? It's here. The basic shade for quartic is this one. Okay, it's sort of like a quadratic, but see the bottom is flatter and quadratic is sharper. Yeah, it's flatter. Even though it's flatter, it doesn't mean this is a straight line. It's actually, we only have one point as the turning point. It just looks flat, but it's not totally horizontal. Okay, it's only the turning point. That point is gradient is 0. Okay, so be mindful of that. Okay, so now if we know the basic shape, this one's pretty easy. We know we just like translate 2 units to the right and 1 unit down, and therefore it would be something like that. Okay, and then you need to find the x-y intercept. Okay, it might not be like this. I just approximate it. Okay, but you need to find the x and y intercept and then connect them. Does it make sense? And for this one, we know we translate 1 unit to the left and 1 unit up, and then it must go, because you have reflection, it must go something like this. Okay, it's flatter. Yeah, and then you need to find x and y intercept, something like that. You can check it with your CAS. All right, so that's all for the sketching bit. Okay, so that is the inflection point form, or we say the turning point form of quartic. Okay, does it make sense so far? Everything makes sense? Okay, then, like I said, we have 3 different forms. And then the next, we're going to learn factorized form. Okay, we're going to learn factorized form. So when it comes to factorized form, first of all, let's try to recall something we have learned before. So how do you find, if you know the factorized form of quadratic, let's say is x minus 2, x plus 5 equal to 0, I think you can very quickly find out the solutions. Okay, Lucy, what are the solutions for this quadratic?
Q or -5.
2 and -5. We just made each term equal to 0, right? And then x equal to 2 or x equal to -5. So therefore, if I want to find the solutions for cubic function, I think you can also borrow the idea from quadratic so that you can work out the solutions very quickly. So what are the solutions for here, Lawrence? For this one?
X equals 2, -1, or -3.
That's right. That's how we do it. Okay. So if we want to solve for the cubic function, if we know the factorized form, it's so easy for us to solve for it. But thing is that not always we will get a factorized form. Okay. So we need to learn how to factorize it. Okay. If I want to factorize it, first of all, we're going to use long division. Okay. So let's do something we have done in primary school. So let's go with this one. So 5a over 23. I want someone to work with me. So Lucy, let's do this together. How many 23 can go into 58?
2.
2. And then 46 here. And then let's continue.
12.
12. And then?
128.
Yeah. And then?
6.
6.
Uh,
No?
no, No, 5.
5. Yep.
115.
Yeah, and then
13. 138.
yep,
6.
6. No remainder, right?
Yeah.
Can we write 5,888 equal to 23 times 256? Can we write in this way? Yeah, of course we can write in this way, right? So the next one we just add up by 1. So we know the remainder must be 1, right? Okay, can we say 23 is therefore a factor of 5,888? Can we say that? Yes, because factor means like, what are the factors for 10? Like 2, 5. 2 times 5 equal to 10. So 2 and 5 are factors of 10. And 1 times 10 equal to 10. So 1 and 10 are also factor of 10. Okay, but 23 is not a factor of this because you have a remainder. Okay, so now we can borrow the idea from long division of 4-digit by 2-digit, and then we can do a 4 terms polynomial divided by 2-term polynomial. Okay, so that would be the same thing. So let's do it together. So I'm gonna write here. Let's see. Okay, so okay, so Lawrence, can we please work on this together, Lawrence? So for this one, it's not 4-digit divided by 2-digit, it's 4 terms divided by 2 terms, but it's similar idea. So how many x plus 2 can go into x cubed plus x2? The idea is I want to cancel out the higher order. So I want to cancel out x
squared.
X squared, yeah, and then
X cubed plus 2x squared.
okay, and then always remember this is minus, right? Just like the
Yeah.
long division we have done before, it's always minus, right? This is minus so that you get 13. This is minus so that you get 12. Okay, yeah, and then x squared minus 2x squared equal to
Minus x squared.
minus x squared
Minus 14x.
minus 14x.
Minus 24.
No,
minus
we don't do this one. We just copy, just like the 2-digit, like this one, right? We're not copying the a until the end, right? So we just copy one more digit.
And then it's minus x.
Minus x.
Equals minus x squared minus 2x.
Yeah.
Equals 12x.
Equal to 12x. Are you sure? So ask yourself, negative 14x minus negative 2x equal to
Minus 12x.
minus 12x and minus 24.
Minus
and then
24. And then minus 12. Yeah.
minus 12. And
yeah, that's it.
Exactly 0, right?
Yeah.
Okay, so which means we can say this polynomial equal to x equal to x plus 2 times this one, right? Does it make sense? Yeah. Okay, so that's how we factorize it. Okay. However, let me ask you, can we further factorize this quadratic? Lawrence, let's continue. Can we further factorize this one?
Yes.
Yeah, what would that be?
It will be x plus 2 times a bracket.
Bracket,
Times.
X what?
Oh, it's x. X minus 1/2. Oh no.
No, that's called complete the square. We're not completing the square. We're factorizing.
I'm not sure what to do.
Okay, Lucy, can we please work out this one? Factorize.
X minus 4 times X plus 3.
Yeah. Okay, so the whole thing will become X plus 2 times X minus 4 times X plus 3. Does it make sense? So that's how we factorize it. Yeah. All right, then can you please have a go on this one? So first of all, let's use long division to factorize it. And then you might get a quadratics and then see if we can further simplify the quadratics. Okay, you have 5 minutes to do it and then I'm going to talk about it. Okay, so you guys already finished. Okay, that's good. Okay, so let's quickly have a look and see whether you're right or wrong. Okay, so let's use long division. Okay, so this one, first of all, it will be x squared, so that it will be x cubed minus this. And then this minus a negative number means you plus a positive number. Yep, so this one would be plus 3x. And then you minus a negative number means you plus a positive number. Okay, it would be minus 4. Okay, and let's see whether we can simplify further simplify this one. Yep. So it will be x minus 1 times x plus 4 times x minus 1. So therefore, it will be x minus 1 squared, x plus 4. Does it make sense? Did you get it right? Let me check. Okay, very good. Lawrence and Joanne, you both got it right. And that is within 2 minutes, I guess. You guys did it very quickly. All right, so one more example. So I'm going to give you only 2 minutes. And then let's see if you can get the factors of this polynomial. Okay, almost 2 minutes. So, okay, Joanne finished, Lucy finished. Okay, so when Lawrence is sending your answer, I will quickly work through with you. I don't know what the answer is. I need to do it by myself. So, okay, so first of all, x squared. All right, so, and then can we further simplify this one? Yes or no? No, why is that? Why we can't further simplify that one? Lucy, why we can't further simplify that one?
Because 7 equals 1 times 7. And you can't use
No.
1, 7, 2.
Oh, I know what you mean. You mean because 7 equal to 1 times 7, which you can't make it cross method. You can't make it the sum become 4x, right? Is that what you mean? But that is not. Sometimes we can't use cross method to factorize it. Doesn't mean we can't factorize it, because we still can use complete the square, or we can still use quadratic formula. It doesn't mean if you can't use cross method to factorize it, doesn't mean it can't be factorized. Yeah. So Joanne, what's the reason why this can't be factorized? Why this quadratic can't be factorized? Consider quadratics, consider when you have solutions. When you say we can't
Oh, it
factorize,
doesn't. There's no x in. There's like no solution for it.
factorize means you will have x-intercept, right? But you don't have x-intercept. How do you know there's no x-intercept?
Because the turning point's above 0.
Okay, I like that. I like that way of saying that is right. The turning point is above 0. How do we know it? We can complete the square, right? So we complete the square. What would that be, Joanne? X
plus 2 squared minus 4 plus 7.
which is plus 3, right? So which
Yeah.
means is 2 units to the left, 3 units up. It goes like this. So the turning point is above s-axis. There's no x-intercept. Therefore, it can't be factorized. That's right. Okay. But is there another way to prove that why it can't be factorized? Something similar to Omicron. What's the previous COVID name before Omicron?
Oh, using delta.
Delta, right? So remember what delta is? The delta, the quadratic, we haven't done quadratic for a while. Okay, the delta equal to b squared minus 4ac, right? So if the delta bigger than 0, it means that, what does that mean? If delta bigger than 0, what does that mean?
There's 2 solutions.
There's 2 solutions. If delta equal to 0, that means
1.
1 solution. And also when we say 2 solutions means 2 x-intercept, right? And 1 solution means 1 x-intercept. And non-solution is when delta less than 0. So means there's no x-intercept. So what's the delta for, what's the discriminant for this one? Delta also called discriminant, okay? So what's the discriminant for this one? B squared minus 4ac.
Negative 12.
Negative 12. So it would be 16 minus 4 times 1 times 7 equal to negative 12. That's right. So negative 12 is less than 0. What does that imply? What does that mean?
No solutions.
No solutions. So we can't factorize it. We only have 1 solution for here. Okay. All right. So compare the 3 examples we have done. Okay. Can you please write down a summary first off? I'm going to give you 2 minutes. I want you to type on the chat. So compare the 3 examples we have done and tell me something that is different. Find out the differences between each of them. Okay, Lucy and Lawrence, you get 1 more minute. Okay, Lucy, when I saying 3 examples is not about the sketching one. I'm talking about a 3 long division example. All right, so let's summarize it together. So for the first one, the factors are 3 bracket, right? Yeah, the 3 bracket. If we make it equal to 0, and if we solve for that, how many solutions we will have? 3 solutions, okay. And remember the second one, the second example here, this is how we factorize it, right? If I make it equal to 0, how many solutions do I have? How many solutions do I have? Give me a finger. If I make this guy equal to 0, how many? Yeah, 2. What are they? What are the solutions? Lucy, unmute yourself. What are the solutions?
1 and -4.
1 and -4, that's right. Okay, and then therefore for the last one, example 3, so it would be x plus 4 times x squared plus 4x plus 7 equal to 0. How many solutions do I have? It's only 1. And what is the solution?
-4.
X equal to -4. Okay, so what summary can we write down now? When there's a polynomial, all right, so the solutions can be 1 solution, 2 solutions, and 3 solutions. There are 3 possibilities there. Okay, does it make sense? There's 3 possibilities there. And we have seen each for one, we have seen the example for each kind of, like each kind, okay? Does it make sense? All right, last 10 minutes, we will do a little bit. So for this one, you can do as homework, and then I will try a question. For last 10 minutes, we will work on the last example, okay? So still, we're doing long division. So 3x squared minus 2r minus 2x squared plus. Okay, can you tell me what's the difference between this one and the previous 3 examples? All right, let's use what we have done just now and see if we can do it. So if I want to cancel out x squared, I would go, okay, 3x here. So 3x cubed minus 3x. Now I can't do it anymore because they are not the like term. I can't subtract them. Does it make sense? Okay, so what should I do? What should I do? So for this kind of question, okay, so we need to, if it's not in descending order, because we know this is in descending order 3, 2, 1, 0, right? But this one is not in the descending order. What we can do is that we can make the mixing term 0 coefficient. So x squared minus 0x minus 1. It would be still the same as the previous one, right? Because you minus 0x, it doesn't mean anything. It just means minus 0. Yeah? Does it make sense? Lucy, what does that face mean? What does that face mean? Yes or no? Does it make sense or not? No? Okay, maybe let's start with this one. This one is a little bit easier. Okay. Okay, so this one is not in the descending order, right? If we just try what we have done just now, it's actually pretty hard because you won't see the like terms. So what I'm going to do is that I'm going to plus 0x squared here. It will still be the same as this one. Does it make sense? Because you plus 0 times anything equal to 0. Basically, you plus 0 for something, it will still equal, right? Yeah. Okay, so now if you plus 0 here, then everything will become the same as just now. So we can do it. Lucy, let's do it together. So what would be the first one? How many x minus 2 can go into the first two terms?
3x.
You sure?
3. Yes.
Square.
Oh, sorry, square.
Yeah.
Yes.
So it become minus 6.
And then 6.
Right? And then this one therefore will become 6x squared plus x, right?
Okay.
Yeah. And therefore it would be plus 6x. Yeah.
Minus 12x.
It would be 13x
13x
minus 3. Okay, so it's not a factor. You can't. We're just doing long division, but it's not exactly. You can you won't get a nice thing. So it will plus 13. So 13x minus 26. Okay, so it would be 23. You have remainder. Okay, but that's how you do it. Does it make sense? So when it's not in descending order, we need to plus something like that. So now let's get back to the previous question. So this is all in descending order, but this one is not. So we need to minus or plus. It's up to you. Plus or minus, it's up to you. It doesn't, you plus 0 or you minus 0 is the same because it doesn't change anything. So let's plus 0x. Okay. So now we can do the long division. So that would be 3x here, right? 3x, so that would be 3x squared cubed plus, so this one times 0 still becomes 0, okay? And then minus 1 minus 3x. Yep. So this one will still be negative 2x squared, and this is plus 6x minus 4. And then you do the last one, which is minus 2. Yep. So minus 2x squared, 0x, and then plus 2. So you still have remainder here. Okay, you still have remainder here. So that's the remainder. Does it make sense? That's how you factorize it. That's how you do long division when it's not in descending order. When you're mixing one term, you just need to put a 0 in front of that term, because that would not change the question, but it would be easy, and it would be convenient for you to calculate. All right, I think that's all for today. Let's we got last 5 minutes. Let's do one more question, and then that's all. Question 2. Okay, so I'm working out for you so that you can compare, you can check your answers. So this one, the hardest bit is that it's not a whole number. It can be fractions, okay? It can be fractions because the idea is for me to get rid of like a 3x cubed. So I would definitely do 3 over 2x squared times 2x so that I will get exactly 3x cubed, okay? So, and then you do the same thing, but just make sure that this is not whole number, subtract by whole number, it's fraction and whole number, okay? So 1 over 4, you will get, oh, sorry, there's an x here, plus 1 over 4x. It would be therefore 5 over 4x minus 2. Okay, so, and the idea is for me to minus, so what times 2? What times 2? What times 2 equal to this? So it would be a over a. Yeah, so it will be something like that. So you will get, and you will have a remainder. Okay, so that is how you long divide, how you do long division. Okay, Lucy, did you get it right? Yep. Okay, something like that, and then you have a remainder here. This cancel out, -2 minus this one would therefore your minus negative means you plus. Okay, so you can work it out, and that is the remainder. All right. Okay, I recorded this lesson, so I will upload on my YouTube channel, and then I will send to you guys when you forget it. Okay.
Thank you.
All right. See you. By the way, in holiday we might do 1 or 2 makeup lessons because this term we missed 1 or 2 lessons. I forgot. I will check it, and I will check it, and then I will let you guys know. All right. So see you. Bye bye. Enjoy your holiday. Bye bye.
Thank you.
Thank you. Bye.
Bye.